Hey guys, Stephen Fleet here. Hey, I want to record a video on something interesting I just discovered as it relates to prime number theorem and then also the Riemann hypothesis. So in previous videos I spoke about this kind of hybrid Dirichlet series, and you have x values that goes inputs, you have your y values, and it predicts all the prime numbers in addition to composites, and then you can predict the location of these composites. In particular, with the square values that are composites, so 5 squared, 7 squared are your first row here, and it's predicted by this equation. Now, one of the very interesting things is that we know from the Riemann hypothesis, you have to be able to control the error term as it relates to the prime number theorem. And that, in essence, if you can control that error term, that's equivalent to solving the Riemann hypothesis. So if you can predict the location of the composites, and you're able to then not only can you predict the location of the primes, but you're also able to know the density of the primes. And so, for example, if we have a y value of about 100, that gives us an x value of about 32. Well, we know from, let's look at the first column, the delta between the values, between any two sets of values are going to be 10. So 8 to 18 is 10, 11 to 21 is 10. And if we did this, 8, 11, 18, first one would be 3, but then when you do 18, 21, and 28, it's only be 2 because you already counted for 18. So it's a little fence post error on the first one. But in essence, it's 1/5, 1/7, 1/11. And so we can take 32 divided by 5. So if we have y is less than or equal to 100, we choose the x value is 32. We know where 32 will fall, which n value. So the n equals 1 equals 2. It'd be less than or equal to 3. So x is 32, so fall right between here. So we can find the prime density simply by the equation governing this first row. So we take 32 divided by 5, 32 divided by 7. That gives you 6.4, then 4.5. 32 minus 11. So in essence, we take 6.4 and add the 4.5. And you add 2 primes to it because the equation only predicts from 5 and above. So you have an x value of 32 minus 11 composites plus 2 primes, and that gives you about 23. And we know that when we stick 100 into the prime number theorem, it gives you about 25. And this actually gives you a density that's even more accurate than L sub I of x. So I'm not sure. Maybe this actually solves the Riemann hypothesis. Let me know. It controls the error term.